Hi everyone, we're going to use the Moivre's theorem to write each expression in standard form. This is standard form. This is different than the previous video we did because it's not in polar form yet. So this is in the complex plane because we have the eyes. So the first thing we want to do is find the magnitude, and the magnitude is going to be the square root of 1 squared plus 1 squared. And this is going to equal square root of 2. So now we have 1 plus I equals square root of 2 times 1 over square root of 2 plus 1 over square root of 2I. And remember, 1 over square root of 2 is square root of 2 over 2. So basically, what we're going to write is, remember, these parts right here are just, this first part here is just your x over r, and this part right here is just your y over r. Okay, so we have to know what cosine of, what yields square root of 2 over 2. So basically we're going to get, you're supposed to know that cosine of pi over 4 is the square root of 2 over 2. And then so is the sine. You have to just know that. Or you can do it the long way. Okay. Now, we know all of this is to the what power? The fifth. So what we're going to do is multiply everything by the fifth. So it's going to be square root of 2 to the fifth times cosine of 5 times pi over 4 plus I times 5, sine, I always leave out sine, sine times 5 pi over 4. Okay, and this is just 5 pi over 4 here. I'll just put it all in one line. All right, so the square root of 2 is 5 square roots of 2. So square root of 2 times square root of 2 times square root of 2 times square root of 2. Now that equals 4. So we have an extra square root of 2. And then we have cosine of 5 pi over 4 is negative square root of 2 over 2. And the sine of 5 pi over 4 is negative square root of 2 over 2, I. All right. These 2's here will cancel with this 4 and make this 2. When you multiply through, you're going to get 2, negative 2 times the square root of 2 times the square root of 2 minus square root of 2 times square root of 2i. And then we're going to simplify this. So square root of 2 times the square root of 2 is just 2. This equals 2. So that's going to be negative 4 when you multiply these two. And this is a minus 4i. This actually should be minus 2i, right? No, this should be 4i as well. So basically this was, I didn't multiply this right, so this should be a 2 in front here. Okay, and that's your answer. All right, so now let's do 2 more of these. And we're going to do this one. And so basically the first thing we want to do is find the magnitude. And so the magnitude is going to be square root of 3 squared plus negative 1 squared. And that's going to yield 2. And we also know that tan of theta equals negative 1 over square root of 3, which equals negative square root of 3 over 3. And we also know that my y is negative and my x is positive, so we're in quadrant 4. So that means my angle is 330 degrees. So let's write this out. We have 2 times sine of 330 degrees plus I cosine of 330 degrees. Okay, and this is all to the 6th power. So basically you use the Moivre's theorem, and you get 2 to the 6th times cosine. Why did I put sine here? Did y'all see that? All right. Cosine of 6 times 330 degrees plus I times sine of 6 times 330 degrees. All right, so 2 to the 6th is 64. And then we have cosine of 1,980 degrees plus I times sine of 1980 degrees. When you make this coterminal, you're going to get 180. So this, when you keep subtracting 360s, you're going to get 180. So 64 times cosine of 180 degrees plus I times sine of 180 degrees. So we get 64, and cosine of 180 is -1, and sine of 180 is 0, so 0 times I is just 0. So my final answer is -64. Okay? And the last one we have is to the 8th power. Oh my goodness. Okay, so basically I'm going to find my magnitude, or you can say your R, but it's going to be square root of 1 squared plus negative square root of 5 squared. This is going to be square root of 6. All right, and I'm also going to do tan of my angle equals a negative square root of 5 over 1. So this is negative square root of 5, which is, when you do the inverse on that, you're going to get 294.095 degrees. So when you work this out, you're going to get 1 minus square root of 5i to the 8th power equals, and I'm shortening this a little bit, square root of 6 to the 8th times cosine of 8 times 294.095 degrees plus I times sine times 8 of 294.095 degrees. All right, 6 to the 8th is going to be, square root of 6 to the 8th equals 1,296, and you're going to get cosine, if you multiply this out, 2352.76 degrees plus I times sine of the same. Let me put this in parentheses. 2352.76 degrees. And then just use your calculator, and you're going to get 1296 times negative 0.9753 minus 0.2208i. And then distribute, and you get negative 1.294 minus 286.217i. And that's your answer. And that's all. Thank you and have a nice day. The next thing we're going to do is the roots. Use find complex roots with degrees. Thank you and have a nice day. Bye-bye.